Chaffed, all onion chaffed all over. Yeah, is this no shoe that use the kubelet, the kubelet. Welcome to the 7th episode of Kubernetes the Hardest Way. Nope. This is my desk.
3, 2, 1, 0.
The No Channel.
Welcome to the 7th episode of Kubernetes the Hardest Way. Today, we're going to set up the control plane. So I wanted to cover a few things about how this control plane is going to be different from a control plane you set up with kubeadm or a lot of other tools that use the kubelet to manage the static pods. So I'll do another video on what a static pod manifest is, but basically kubeadm uses static pod manifests to run your control plane. And that means that even on your control plane nodes, you need the kubelet running because that's what runs the static pods that are the control plane. Your control plane consists of the API server. If you're running a stack configuration, it includes your etcd server. So in a kubeadm and a lot of other deployments, your control plane has the kubelet running. But the kubelet doesn't have to run on your control plane nodes. In this configuration, we're actually going to run the control plane nodes, the components for the control plane nodes in systemd. And because of that, we won't run kubelet at all. That means if you do a kube control get nodes, they won't list the control plane nodes. That doesn't mean they're not there, that they're not working. It just means that kubelet's not on them because the kubelet is the thing that reports to that. So that's the major difference between this. I'm not arguing whether one way is better or worse or whatnot. So the control planes aren't anything special. They're just nodes that run the controller manager, the API server, and the scheduler. That's all it means. That's the whole concept of a control plane. And how you run them can be different. We're using systemd. kubeadm, the kind of de facto standard, uses containers themselves for these things and runs them through static pod manifests. That's all the control plane is. Also, if you're running with kubeadm, it runs natively in a stacked mode, which means the etcd cluster is running on your control planes as well. In our configuration, we're running etcd separately from the control plane, so our control plane doesn't have that. Okay, so with that out of the way, let's go ahead and install these components on our control plane nodes and get them communicating together. It's really not that hard. Mostly all we have to do is make sure that they have all their certificates that we created for them. They have the we created kubeconfig files with them to tell them how to communicate. If you remember, the kubeconfig files are the things that tell them where the certs are and where to communicate with the other machines. We've created those, and then all that there's left to do is to create the service files for them. So let's go ahead and do that really quickly, and then we'll be done. So this is where we put all of our files. And you can notice these things. Now, I want to do one thing here that is going to up those layers of security. If you remember the layers of security, here is one more layer of security that you can do for your Kubernetes control plane. What do we have here? Layers of security. That's what we have. We have layers of security, ladies and gentlemen. The onion is a perfect representation of how you should operate your not only your Kubernetes cluster, but your applications you run on top of it and your entire infrastructure, your hardware infrastructure that you run. Layers of security. There is no one silver bullet. It is about putting on layers and layers of security at each and every step. All right. So what we're going to do is create a encryption file. All you have to do for this is make something like, you're going to set it to this here. Basically, all that this is creating some random characters. So we can do that. Now we can echo this. And you can see our kind of random set of things. And this is your encryption key. Keep it secret. Don't post it to the internet like I'm doing here. And what we're going to do with this is we're going to make a file like this. So what we're doing is we're putting this secret into this file. And now we can check the file out. And you'll notice our secret key is in here. I could have done this without you guys seeing it because, I created the file with the cat and then it was never exposed. But this is just a encryption config for Kubernetes. And what we're going to do with this file is encrypt all of the data that we store in our etcd cluster. So if our etcd cluster was compromised, because of our layers of security, it would still be safe, or encrypted at least, as safe as that is. Again, this is layers and layers and layers of security. That's how it's done. All right, so let's move on to the more fun stuff. So over here, we're going to SSH into our CP0. So the next thing that you're going to need to do is obtain all of the things that need to run. So this is our Kube API server, Kube controller manager, Kube schedule, and kubectl. Kubectl is just the tool you'll use to interact with your cluster. Now that they're all downloaded, you're going to want to make them all executable. Again, this is not how you run a real production cluster. Because you don't just make things you download from the internet executable. But once we've made them executable, we're going to move them into user local bin. So we're just moving these here. All right, so now we need to configure the Kubernetes API server. So the first thing that we're going to want to do is we're going to make this folder. This is where you're going to store the cert information. And then you're going to want to move that information over to there. So we're just moving the CA PEM, the CA key PEM, Kubernetes key PEM, Kubernetes PEM, service account key PEM, service account PEM, and the encryption config. That's the encryption config for storing information in etcd into varlib Kubernetes. If you're following Kelsey Hightower's documentation, he gets a internal IP address. You're just using the IP address of this. We don't have an internal and external IP address. You could designate two network adapters, but we only have one on this. So it's both internal and external. Now, what you're going to want to do is grab yourself this. So we're going to vim this Kube API service. And you notice this is where it's going to advertise. This is wrong. So if you want to go here, you can do IPA. This is going to tell you what your IP address is. So we are at 10. Here are your etcd servers. All three of them we stood up. This is a very easy to understand file for the most part. Your advertised, this is what you're saying your IP address is, your advertised address. Allow privileged, how many API servers there are going to be, audit log, bind address, a lot of just standard web server stuff. And if you look down here, here are where your certs are used. All right, so what we have left are our services. So let's go ahead and look at these. I need to update them. Kube controller manager. Everything here looks to be correct. So actually, let's look that up. So you'll notice here that there's this kube config for these. And if you remember back to my kube config talk, the kube configs are merely the file that tells things how to communicate with a Kubernetes API server. So we moved these into varlib Kubernetes. This is the CA key. And you'll notice here's the private key file. This is the thing we're using to encrypt our services. And you'll notice that it just has the certificate data for Kubernetes, for the API server, with what user it's using, and the data for it. So that's it. And the context to use, which is just the default one. So that's all the Kube Controller Manager is, and it tells it what to use and where to use it. Now that we have all of that, we can move these service files to their proper location. So let's move the API server.service, the Kube controller service, and the Kube scheduler service, all to etc systemd system. I want to use sudo. Boom. All right, so now that those things are moved over there, we're going to want to move that controller manager kube config here. So we're just moving this kube controller manager kube config to varlib Kubernetes. That's where we told everything it was going to be. It needs to be there. And we need to move the kube scheduler kube config. So do this, move the kube scheduler over to varlib Kubernetes. So that's the kube scheduler kube config. Again, this is just how the kube scheduler is going to communicate what service, what certs it's going to use. Then we're going to create this file here called the kube scheduler. You can just copy and paste this here. So in etc Kubernetes config kube scheduler YAML, we're just giving it a scheduler configuration, and this tells it which kube config to use. That's how the scheduler reads this. We have our kube scheduler, and now because we're running these on systemd, we're going to need to reload the systemctl daemon. So you can do that with daemon reload. Then all you have to do is enable and then start these services. You can do this. And just as a quick thing, you could run this enable, and then you could run start with the same thing. Or you can just do now. Now we'll enable the service and start it. All right, so there's only one other thing that we're going to do today, and that is just quickly and easily set up a Nginx reverse proxy on the control plane node. What this is going to provide us is a way to hit the health endpoint without a certificate. So the Nginx endpoint is not going to require a certificate. And then it's going to inject a certificate into that request as it makes the request to the API server, because the API server requires a certificate for all requests. And this will enable us to hit that health endpoint from like a load balancer or something else that's not going to provide it with a certificate. Because we're using Leap as our base image, it's zipper. Install Nginx. All right. Once we do that, we need to configure Nginx. So let's go to its configuration. And in here, all we're going to do is make a very simple server. So this server looks like this. So all you're doing is passing this health check endpoint, and you're using a cert that you have. So you're exposing this health endpoint to services without this. So you'd be able to call the health check endpoint without providing ACA, because it's going to call it for you. So that's all you have to do. Once you do that, so make sure when you're here you use sudo, or else you won't be able to save. It's okay. We've got it. You also want to enable it so that it will restart when the thing starts. And now we can tell that our service is up and running. Beautiful. So, as you can see here, these things return healthy, and it tells us it also returns etcd. We don't have any errors. You have to be in the right directory to run. We're telling it to use this kube config here, which was in our home directory. This is the admin, or this is the kube config you would normally put in your .cube folder and use. And yeah, so we've stood up our cluster. At this point, you could also check the local endpoint. So let's do that. You can run this here, and you will get an OK back from your local health endpoint. And you didn't pass a cert because you can't with that, or didn't. And there you go. We've set up our control plane and it's ready to go. The only other thing that you have to do is do 2 more control planes. And then if you'd like to load balance the requests between your control plane, because unlike etcd, which only really one of the etcd nodes is the current leader, all of the control planes can really handle a request. And so it's really best to put your control plane behind a load balancer so that they get their load equally distributed, as well as if there is a control plane that goes down. So if you hardcode an IP address or an FQDN and that node goes down, so for whatever reason one of your control plane nodes goes down, your request will still make it through. Your load balancer should be smart enough to send it to a node that is still up and working. So it's really best if you put a load balancer, and I'll show you guys how to do that with an HA proxy load balancer. It's very simple to set up. So really all we have left to do is create some worker nodes, add them, join them to the cluster with the correct certs, and then set up some very basic network routing. We don't have a provider like Flannel, Calico, Cilium. We're not getting that in depth. We're just going to do some very basic network routing. If you like this video, remember, give it a thumbs up. And if you want to see more content from me, make sure to subscribe. And if you really didn't like the video, give it a thumbs down, but leave me a comment on why and what you'd like to see more of and how I could make it better so that it's more entertaining for you. Hopefully we all were slightly entertained, as well as maybe we all learned something. I know that I did. There is all this onion shaft laying around. Ugh.